This is Trey Underwood. I'm in lab M06. This is my lab 3 report about constant velocity motion. I observed a bicycle tire rolling in the video and made a model of it. The main result was applying the momentum principle in Newton's second law, and that F net is very effective in predicting the motion observed in the experiment. Here's the video. It's just a video of my girlfriend riding a bike. I used the center of the front bicycle tire as the average position in the video, and it's marked by these red squares, which you'll see in a second when I play the video. The origin was set right at the center of the bike tire, just to make it easier, so that starting the initial position would be 0. It's moving along the x-axis, which is this purple line right here, and even though it's the video, the bike will be moving left, it's still moving in the positive x direction. And here's the video, and you can see the average position is represented by those red squares, just right at the center of the bike tire. And you can see up here that since the graph is going up, that it is moving in the positive x direction. The video is about 1.4 seconds long, and the diameter of the bike wheel was used to be the length scale of the video, and the diameter is about 0.559 meters. And notice that the bike doesn't slow up or doesn't slow down or speed up any during the video. It's in constant motion. And here's the model. The mass of the object, the mass of the wheel, is about 0.7 kilograms. That was looked up. That's about the average for the standard bike tire. The initial position, since it started at 0, since it started at the origin, is 0, and the initial velocity, which is also the average velocity, since it's in constant motion, was calculated to be 2.694 meters per second. That average velocity was calculated by taking the change in position over the change in time. You can see right here, and this is information I was taken from tracker data. And the total video is like I said earlier, it's a little less than 1.4 seconds long. And then if we go here, we can see more of what was used to produce the model. The time was between 0 and 1.4 seconds. And as you can see, here's the formula for the final velocity. But the final velocity is predicted to be the same as the initial, because F net equals 0. By applying Newton's second law, we find that the object will be in constant motion because there are no forces acting upon it. And the only way for the final velocity to equal the initial velocity, which is what is predicted to happen here, is that F net is 0, because the mass cannot equal 0, because you can't have a massless object, and the time can't equal 0, obviously. And then here we have the model. The ball right here in the center is right at the origin, and it represents the bike tire. And if we run this, we see that it moves at a constant speed to the left in the positive x direction, and the further it moves, you can see also that the higher the graph goes, the further it moves in the left direction. This information was posted into a plot. The best way to compare the experimental data and the model, the data from the model, was to place them into the same plot. As you can see, the somewhat transparent green squares is a bunch of data from the model, and then the red line represents data from the experiment. As you can see, it starts from 0, which would be the origin, since the bike tire started at 0, and you can see that they're fairly straight, both of them. That's because the velocity is constant for both of them, since F net is 0, and since they are so right in tune with one another. They have pretty good agreement between the two, which means they're a really good representation for each other. And then the what if discuss briefly how your results would change and stay the same if you made your choice of origin different. We can go to the model to look at this right now. And here, if we just change the initial position, instead of being at 0, at being negative 1.5, you can see here. Let's rotate it so that it will be the same. And so let's move in the positive x direction, just as the previous video. You can see that it doesn't start at 0. It starts at negative 1.5 and moves the same distance, but it does not. And it goes in the same velocity, but it starts at a different position because the origin is different. And you can see the same in the graph. It starts, instead of at 0, it starts at negative 1.5 down here. And finally, we'll go to the last part. What does it mean? Is it possible to say how many pushes or pulls are being added together to get a net force of 0? Obviously, all the forces acting on the tire cancel out because the net force is 0. The only forces acting on it should be gravity, which is pushing down on the bike, and normal force from the road, which is pushing up on the bike. And those should all cancel out, but it should be, since F net is 0, it should be moving at a constant velocity. But this also implies that if F net is not 0, something will not move at a constant velocity because it has a force in a particular direction that will be changing its velocity in